right, mid-unit 4 review. The elk population in a forest is currently 230. 5 months later, the population's tripled. Write an exponential equation to describe the population in months, and then use that equation to predict what the population is in 12 months. So the key pieces of information here is the starting population, which is 230. The pattern, which is that it triples, or we would also call that our growth rate, and it triples every 5 months. So we have to make sure that we take note of that as well. And it triples every 5 months, so that's going to affect our exponent. And then we want to know what happens every 12 months, so that's how we would plug it in. Your equation, you start with your initial population or your starting point, so that's going to be 230. Your pattern is that it tripled, so inside parentheses we're going to write a 3 for tripling, but it only triples every 5 months. So your exponent is going to end up being a fraction. Originally it's going to be m over 5, m representing whatever months that you're plugging in, 5 representing that it triples every 5 months. So then to answer this question right here, use your equation to predict the population in 12 months. You would plug in a 12 for m. So that would look like this: 230 times 3 to the 12 over 5. And whatever you get in your calculator would be your answer for that. For number 2, it's going to be much of the same. You put $1,500 into an investment account with an interest rate of 4.3%. Create an equation to model the amount of money in the account after T years. So our starting point, our initial investment is going to be $1,500. Our growth rate is 4.3%. And it's increasing, so remember that we have to put the 1 in front of it and rewrite it as a decimal. And then our length of time is going to be in years. So what that equation looks like is 1,500 times 1.043. The 1 representing the increase, the 0.043 representing 4.3%. And we're going to call it to the power of t in years. Number 3, a scientist begins with a 117 milligram sample of a particular isotope, which has a half-life of 9 hours. So there's our starting point, 117 milligrams, and our pattern, which is the half-life, meaning that it gets cut in half, and our length of time is going to be 9 hours. So that's going to affect the exponent. So for the first question, how much of the sample will remain after 5 hours? To set that up, you would have 117 times 1/2, or 0.5, whatever you choose to use, to the 5 over 9, because it's 5 hours and it gets cut in half every 9, so you'd have to write that as a fraction. For the next 2 questions, after 1 day, you're going to plug in 24 for the hours, because there's 24 hours in a day. So that would look like 117 times 1/2 to the 24 over 9. That would be for the 1 day. And for 20 minutes, you would want to convert 9 hours into minutes, so 9 times 60, and put 20 over that. For this one, you buy a car for $4,300 every 2 years. The value drops by 16%. Create an equation to represent the car over time. So first term, this is the value that it drops, and this is how often it drops, every 2 years. Okay? So every 2 years it drops 16%. We're going to write that in parentheses as the opposite of 16. So it would be 100 minus 16. It's going to be 84. So 0.84 is what we're going to plug in. Your equation is going to be 4,300 times 0.84 over 2, 2 representing the years. So to find the value after 3 months, we would have to change this 2. Instead of 2 years, we'd have to call it 24 for 24 months in 2 years. And plug the 3 over it. Scrolling down to number 6 for the graph. This is going to be your starting point. So this graph represents the value of a car in thousands of dollars. So we're starting at $16,000, and after 2 years, it ends up at $9,000. So that's what the 2 represents. Those 2 years goes to $9,000. So we're going to create an equation. Your first term is 16. We got to figure out what our pattern is. To do that, you divide 9 by 16. If you plug that into your calculator, you get 0.5625, which as a fraction is 9/16. And we're going to put that exponent over 2 because it happens every 2 years. So we'll call it t over 2. The original value of the car was the starting point, so that's $16,000. Make sure you put 16,000, not 16, because it tells us up here that it's in thousands. And what will the value of the car be in 10 years? You would plug in 10 for t. So you'd have 16 times 9 over 16 to the power of 10 divided by 2.